Hi everyone, my name is Anelisha Jwayo, and here we have a topographic map that we will be looking at. So have you ever looked at a map and thought to yourself, what does these brown squiggly lines have to tell us about mountains, valleys and rivers? Well, that's the magic of a topographic map. It doesn't only show us where roads and towns are, but it also tells us more about the height and the shape of a land. So towards the end of this lesson, you guys will be able to read contour lines and identify heights on a topographic map using height indicators such as your spot height, your trig beacons and benchmarks. And also you'll be able to calculate gradient, which helps us determine whether the land has a steep or a gentle slope. So buckle up your seats because the land is about to rise. Before we continue with our lesson, I would like us to first ask ourselves, what is a topographic map? So a topographic map, it is a special kind of map that represents the three-dimensional shape of a land on a flat piece of paper. So unlike ordinary maps that shows us the towns, roads and rivers, a topographic map also shows us the elevation of a land, which shows us whether the land is high or low above sea level. So that is done through contour lines and indicators of height. A topographic map is important when it comes to geography, engineering, farming and also hiking, because it allows us to see the land in full details without us being there physically. So now, boys and girls, we will continue with our lesson where we'll be talking about how we can understand heights by looking at a topographic map. So we'll first start by talking about contour lines. So what are contour lines? Contour lines are these brown lines that we find on a topographic map which join places of equal height. So looking at our topographic map, we have these brown lines. So let's make an example of, let's say these brown lines are indicated at 200 meters above sea level. So this means that each and every point that is found along these lines, it is indicated above sea level at 200 meters. So we also have rules when it comes to contour lines. So contour lines cannot cross each other because we can't have the same place having two different heights. So the spacing of contour lines also tells us how steep or how gentle the land is. So they also loop closely together even if it is beyond the borders of a topographical map. Here we have examples of contour lines. There is a question that I want to ask you guys since we've talked about contour lines. So looking at these two different kinds of contour lines, which one has a steep slope and a gentle slope? So we will look at A. So A has a steep slope because the contour lines are closely together. Like I've said previously, that contour lines help us determine whether the slope is steep or gentle by looking at how spaced the lines are to each other. So at A, we have closely spaced lines, which means that the slope is very steep. So looking at B, we have a gentle slope. Like I've said to A, at A, the reasons are the same, but it's just that since the lines are very widely apart, it indicates that the slope of that land is very gentle because they are very widely spaced. To our second height indicator, which is a spot height. So what is a spot height? A spot height, it is usually indicated in a topographic map by a small black dot which has a number beside it. So looking at our topographic map that we have here on block A1, we have a spot height. There is a dot and a number beside it. So the number beside it on our map, it is 1079 meters. So this number beside the black dots usually indicates the exact height of that point above sea level. So our third height indicator is a trig beacon. So a trig beacon on a topographic map, it is usually indicated with a black small little triangle. So here in our map, we have our trig beacon on block E3 right here. So a trig beacon, boys and girls, it has a number beside it. There's a small black triangle, remember that? A small black triangle. It also has a number, but it doesn't have one number, it has two. Right here is an example taken from our topographical map. We have the number here right at the top of the triangle, which is 136. So this number, it tells us the exact number of the trig beacons that are found. And below the triangle, we have the exact highest point of a mountain. So which means that a spot height, it is usually found on it usually tells us the exact point of that, the exact height of that point, and a trig beacon, it tells us the exact point of the highest mountain found within that region or a place. A slope, it is an angle of a land that indicates whether it is steep or gentle. So on a topographic map, like we've said earlier, that we use contour lines to indicate whether the slope, it is gentle or steep. So we can identify that by simply looking at the lines and tell if they are spaced closely together, we can tell that the slope, it is very steep. And if the contour lines are wide apart, that clearly indicates that that slope, it is very gentle. So
I'm going to teach you how to calculate a gradient. Firstly, you need to know if you are calculating a gradient, you need 2 points. Secondly, gradient is always in meters, not in centimeters. And then lastly, your answer or final answer must be in ratio. Those are your 3 points you need to know. So we need 2 points. Number one, we have our trig beacon that is located in E4. We are going to use it. And then our second point is located in D4, of which is our spot height, 1,411 meters. And then our trig beacon is 1,382.9. That is our trig beacon. So the formula of gradient is gradient is equal to vertical height, of which is our VE, divided by distance, of which is our horizontal equivalent. So you need to calculate the vertical height first. So vertical height is equal to you need to find the difference between the 2 points, of which is our trig beacon and spot height. So you need 1,411 meters minus 1,382.9, of which is 28.1 meter. Because our height or our height, of which is spot height or trig beacon or benchmarks, are always in meters. The second step, you need to calculate the distance between those 2 points, of which is our trig beacon and spot height. I already calculated the distance or measured the distance. Our distance is 6.2 centimeters. So I already explained that gradient must be always in meters. You need to convert centimeter if you have an answer that is in centimeters. So we have 6,2 centimeters, so you need to convert it into meters. So because we are using a topographic map of which our scale is 1:50,000, we need to convert it. So we will take 6,2 centimeter multiplied by 500 because we are using a topographic map. So distance is equal to 6,2 centimeter multiplied by 500, of which is 3,100 meters. That is our second step. Our third. So in our third step, you do not need to include the unit where I'm talking about meters. So you need to take your vertical height, of which is 28,1 is equal to your distance, of which is 3,100. So you need to divide your vertical height by this number, and you need to divide your distance by vertical height, of which is 28,1. So 28,1 divided by 28,1 is equal to 1, and then 3,100 divided by 28,1 is equal to 110,32. That is your answer. So I already explained it when I started this how to calculate the gradient. I said your final answer must be in or always in ratio. So this indicates that your slope or our slope is flat or gently.
So now, boys and girls, we are approaching the end of our lesson. But before we end our lesson, I'd like us to focus on the characteristics that we have on our topographic map. On a topographic map, we usually have different kinds of characteristics or landforms that we find on a topographic map, which are indicated by our contour lines. So on our topographic map that we have today, we only have two types of characteristics or landforms. We have a flat top hill and a pointed hill at the top. So we can identify them by reading our contour lines. So looking at our flat top hill, we can identify that the top is flat by reading our contour lines and seeing that towards the center of our contour lines, they are spaced widely apart. So that indicates that the top, it is very flat, which means that that might be a plateau, which is a type of a landform. So moving on to our second characteristics, looking at our pointed top hill, we can see or identify that by reading our contour lines and seeing that towards the center, the circles are spaced closely together. So that indicates that the top of that hill, it is very pointy. So